Krishna, Assistant Professor, EC Department, in the subject Analog and Digital Electronics, Unit number 3, Lecture number 4, Low Frequency Response of Field Effective Transistor. At low frequencies, the gain decreases due to the network of capacitors. Here, the network of capacitors used are CG at the gate terminal, at the output terminal CC, and a bypass capacitor at the source, that is CS. CG, CC, and CS will limit the gain of the amplifier circuit. So, this is the common source amplifier in the fixed bias configuration. Now, in order to find the cutoff frequency due to each of these capacitors, let us first see the effect of the capacitor CG. So, due to capacitor CG, now let us consider the remaining entire system is replaced with its equivalent resistance, that is Ri. Then in that case, the cutoff frequency due to CG is FLC is equal to 1 by 2 pi RC. Now the resistance here will be the resistance of the signal source plus the resistance of the amplifier system into the CG. So 1 by 2 pi R signal plus R into CG, where this input resistance is RG, that is gate resistance RG, because in the equivalent circuit of this amplifier circuit, now we have open circuit between gate and source. So therefore simply we have RG. So Ra is equal to RG. Effect due to the coupling capacitor CC. Now the remaining circuit will be replaced with its equivalent resistance R0. So now the cutoff frequency due to CC is FLC is equal to 1 by 2 pi. The resistance here is R0 plus RL into CC, coupling capacitor CC. This resistance R0 looking into this circuit is the parallel combination of small rd with the network resistor rd. Now the effect due to the bypass capacitor CS. Here the cutoff frequency is 1 by 2 pi R equivalent. Looking from this source terminal, the equivalent resistance is R equivalent. Then in that case 1 by 2 pi R equivalent into CS. So where this equivalent resistance is R is parallel with 1 by GM. The low frequency response of FET here is plotted. FLG is the cutoff frequency due to capacitor CG, FLC is the cutoff frequency due to CC, FLS is the cutoff frequency due to CS. Whichever is having the higher value, that frequency is considered as the lower cutoff frequency for the FET amplifier. High frequency response of FET amplifier. The high frequency response depends on junction capacitances between the terminals, that is between gate and drain CGD, between gate and source CGS, between drain and source CDS, and also the wiring capacitors at the input and output side. At the input side it is represented as CWI, at the output CW0. The high frequency equivalent circuit of this amplifier is drawn here. Now at the input side, all the network capacitors will be short circuited. CG is shorted, CC is shorted, and CS is shorted. Now at the input side, now we have the capacitance due to wiring CWI plus CGS plus due to CGD, and at the output side, now we have the output capacitance, that is due to CW0, CDS, and due to CGD. By applying Thevenin's theorem at the input and output side, we get the networks like this. So the equivalent resistance at the input side will be the parallel combination of R signal and RG, and the capacitance here is CWI plus CGS plus due to Miller effect of this CGD, that is 1 minus AV into CGD. So the higher cutoff frequency is 1 by 2 pi R7N into CI. Similarly, at the output side, 1 by 2 pi R7N output into CO, where R7N is capital RD parallel with RL parallel with small rd. And output capacitance C0 is CWO plus CDS plus Miller effect of CGD. Miller effect of CGD is 1 minus 1 by AV into CG.